Good day, viewers. You are welcome to Soluble Tutors. I would like to show you in this video the 12 mistakes that students always make in algebra. Simple. Algebra is very, very simple, but there are some deadly mistakes, which are 12, simple and deadly, that students always make. So I would like to show you in this video, and I would like you to watch through to the end, because the last mistake, which is the number 12, is the most important one. I would like you to subscribe to this channel, press the bell icon, and like this video. And I would like you to please share with friends so that they can also benefit. Number 1, incorrectly reducing rational expression. The first example that we are going to be taking there is x squared plus x minus 3 all over x squared plus 2. In most cases, students always cancel s squared in the numerator with the s squared in the denominator. And this is very wrong. When they do that, they can get the answer of x minus 3 over 2. It is very, very wrong, because x squared plus x minus 3, it is addition that is joining x squared to the other, not multiplication. So you cannot divide that. Let's go to another example. 5x plus y divided by x. Some candidates will divide and cancel x and x. It is plus that is combining them together, so you cannot divide it. Okay, so the third example under there is 2 plus root 3 divided by 4. Some will say 2 into in the numerator, and they will use 2 to cancel 4 in the denominator. That is very, very wrong. So let's go to the second one. Not understanding what like terms are. Example that we have there, we have x squared plus x. Most of the time, students add it together, x squared plus x, they get x raised to the power of 3, which is very, very wrong. X squared and x are not like terms because they are having different powers. Another example is sine theta plus sine squared theta. Sometimes students add it together to get sine of cube theta, and which is very, very wrong. Please, you have to take note of that. So the third mistake, incorrectly expanding binomials. There's an example there. We have x plus 2 in brackets raised to power of 2. Some students will make a mistake of not expanding it properly. They just distribute the square on top of the x and 2 to get x squared and 4 respectively. That is very, very wrong. X plus 2 all square means s plus 2 into bracket of another x plus 2. Please, let's note that. The fourth one, incorrectly taking roots. We have an example there where we have root of x squared plus 4. Some candidates will believe that the square root will cancel the square. They also find the square root of 4 to get x plus 2. This is very wrong. The only time you can do that is if x squared and 4, it is multiplication that is in between them. That's the only time you can do that. So you have to take note of that also. Now, number 5, not using the distributive properties correctly. We have an example there. Minus 2 into bracket x minus 3. Some candidates get it as minus 2x minus 3. They were correct in one way by using 2 to multiply what is in the bracket, but the minus is the problem, because minus 2 times x is minus 2x, but minus 2 times minus 3 should give us plus 6, and they are even having 3 there instead of 6. So that's very, very wrong. Now, 5 minus into bracket of x plus 3. The minus should open the brackets. So which means our answer should have been 5 minus x minus 3. And at the end of the day, it should have been 2 minus x instead of 8 minus x. Number 6, not following the order of operation. In the order of operation, power is the most powerful thing, as the name says, because we have BOD, board mass. In that area, we have bracket, order, division, multiplication, addition, and subtraction. It is not of order. So when you have 3, example there is 3 into bracket of 2x plus 1, all raised to power half. Because of the power, we are not allowed to use 3 to open the bracket. And that's what the candidate does here. Okay, which is very, very wrong. So another example is 5 minus 2 cos 25 degrees. Some candidates will just say 5 minus 2, which gives them 3 cos 25. That's very, very wrong. In the order of operation, 5 minus 2, between 2 and cos 25, it is multiplication. So we have to honor that first before we go for the subtraction. Another example we have there is x plus 3x ln x. That candidate over there added x plus 3x, which is very, very wrong. Because between 3x and ln x, we have multiplication. That should be taken care of before we go for the addition. Though they are like terms, but we cannot add. So let's go to 7th point now. Number 7, cross multiplying every time 2 fractions are next to each other. You can only cross multiply if 2 fractions are next to each other, but equation sign, which is equal to, is what is separating them. So that's the only time you can cross multiply. But when you have multiplication, it means numerator multiplies numerator and denominator multiplies denominator. So in this aspect now, the student cross multiplied and 3x times 2, we say is equal to 7 times 5, and equal to is not even part of the question there. So we don't have to include it. So that's totally wrong. Number 8 says not using the zero product property. Example under that, we have x into x minus 1, close bracket, is equal to 2. In this aspect, it will be wrong for us to say is either x is equal to 2 or x minus 1 equals to 2. We must use the zero product property. It's the best way for us to solve things like that. So when you use zero product property, it means you have to open the bracket first, where you have your x times x give you x squared, x times minus 1 give you minus x is equal to 2. So the 2 will have to come to the left side to give us x squared minus x minus 2 is equal to 0. So we have to factorize before we can get the answer there. Let's take note of that. So number 9, dividing by a variable or a function. When you divide just anyhow, it means there is a problem. Let's take an example. X is equal to 4x minus x squared. Truthfully, okay, x is common to all values there. So the candidate there made a mistake of dividing through by x, and that is not correct. Okay, so that equation does not lead to 1 is equal to 4 minus x. We have to be careful. You collect the like terms and you factorize using product property. Another example there, we have sine x cos x is equal to sine x. This does not lead to cos x is equal to 1 because this candidate there divided throughout by sine x, and that is not correct. Please, we have to take note of that. Now, point 10 now. Point 10, not understanding properties of logarithm. Yes, we have to understand the properties of logarithm properly. An example we have there, we have log x is equal to log x plus log into bracket of x minus 4, close bracket. Okay. This does not lead to x is equal to x plus into bracket x minus 4 because the addition between log x and the log of x minus 4, we have to compress it using one log to represent, and the addition will turn to multiplication, and after that we use quadratic rule because it will lead to a quadratic equation. We use quadratic rule to solve it. Another example we have there, log x over log y. You cannot cancel log and the other log. You can't cancel it. That is very, very wrong. So you can't, this can lead to x over y. We have to take note of that. Point 11, not understanding function notation correctly. Now, we have an example there. X divided by sine x. This is not equal to 1 over sine. You can't cancel the x in the numerator with the x in the denominator because sine, any trigonometry cannot stand alone without the variable between in the front of them. So x is very, very important to sine x. So you dare not cancel it. Okay, we have another example down there. X divided by ln x. Ln is also like sine or like log. That's the natural log. So you cannot cancel the x. So we have another example, x squared sine x. The candidate gets sine x cubed. It means the candidate multiplied the x squared by the x in the front of sine x. No, you can't do that. Okay, let's go to point number 12. Not understanding how to undo operation with rational expression. We have an example there. We have x divided by y plus z. You cannot distribute the denominators. That is not possible. So this cannot give us x over y plus x over z. No. The only correct one is what we have done there. We have another example which is correct. We have y plus z over x. Since x is the denominator, you can distribute x because it's only single denominator and that can be distributed. So this can be equal to y over x plus z over x. Another example we have there, 1 plus sine x all over cos x. The denominator which is cos x, which is single, can be distributed into the numerators. That's the only way it can go. So these are the 12 mistakes that a lot of students makes in algebra. In this channel, I also have a lot of videos which has discussed about errors and mistakes that make a lot of students to fail, and I will also be making more videos. So I will enjoy you. If you are still new, if you have not subscribed, please like this video if you like it. Subscribe to this channel, press the bell icon so that you'll be notified anytime we release new video. Share with friends. See you in another video. Thank you.